Okay, our last example then is another classic vectors question. You'll see the picture here. Find the tension in the wire and the compression in the pole. The sign is 20 kilograms. So similar to the other sign question that we had, except instead of being suspended by two wires, we've got a wire and a pole. These two tensions, the tension and the compression, are the components that are made up that require and hold this sign in place. So it's going to start just like the one before. We have to figure out how much pole gravity is having and what forces is there that's pulling on this sign to fall straight down. So we know that there's this picture right here, and that is our force due to gravity. You recall that that's mass times gravity, so that's 20 times our constant of 9.8 equals 196 newtons. By the way, just as a heads up, some questions try and trick you and give you the force due to gravity in newtons already. This one is in kilograms, so we need to multiply it by 9.8 to get 196 newtons. But in other questions I've seen, it says the sign has a force due to gravity of 196. And people make the mistake of multiplying that by 9.8 and getting a huge number when it was already done for them. Okay, so there's our force due to gravity. We know then that there must be an equal force pulling straight up called the equilibrium. So let's clone this, flip it, and I'm actually going to change it to a dashed line just for fun. And we know that this one then is up here. So there are two tensions that are happening here. We've got the tension in the wire, which goes out along here. And again, we don't know how long this is. It's actually looked like it's being the same length. So what I'm going to do is just shrink this up, which means shrink this up, just because I didn't want it to line up exactly with the length of the wire, to emphasize the fact that this blue vector can be as short or as long as I want. It could actually be out here, depending on how heavy the sign is, but I'm just going to pretend it's about there. Now, the interesting thing is we have that tension in the wire, which I'll call T1. And then the other one, we had a second tension that was T2, and it was also going up. But notice the problem of if we said that there was an equal tension in this pole and we drew it this way. Well, the problem, of course, would happen that if we take this and try and add it on, we see that it's going in the wrong way. So what we say is the compression is actually flipped around. And the compression is actually coming out of the wall. And that's allowed because of one of Newton's laws. Newton said that for every action, there's an equal and opposite reaction. So if you stand and push on the wall, there's an equal force that is pushing back, the wall is pushing back on you, and that's why you're standing still. So the compression is that wall pushing backwards. And this is what we need because we need this compression to be going in this direction so that it adds up to what we want it to be. So this is the compression. And I'll just make sure that it's down here as well so you can see that it's about that long. And there's your C vector. So again, just like the other question, we could do the math right here, but I think I'm going to take these and actually draw a vector diagram so that it's nice and clean off to the side here. So there's my T wire, my compression, and my result, or my equilibrium, excuse me. It's going straight up. And I've got the picture over here. There are some information that I know. This is T in the wire. This I've called C for compression. I know that since this is 196, that this must also be 196. So this is 196. And I do know a little bit of the angles. You'll see that it's given to me that the angle between the pole and the wire is 55. So where is that in my picture? Well, you'll notice that if that's 55, I can use the Z pattern to say that this is 55, and then that's clear that this is 55. What's good about this is the pole is at a right angle to the wall, and so we probably don't have to use the sine law or cosine law again. We can just use SOHCAHTOA. Also, if this is 55 and 90 subtract from 180, we get that this is 35 degrees. And we have all three angles in our picture. So now we can finish the question pretty quickly using SOHCAHTOA. Our first unknown is T1. So that's one of the information we need. I'm going to use the 55-degree angle. So T1 is the hypotenuse. The known side over here is opposite. So that's going to be sine 55 is equal to opposite, which is 196, over hypotenuse, which is T1. So we need a little bit of work here. We're going to have to first bring this up here. T1 times sine 55 equals 196. And then to get T1 by itself, we're going to divide that. So it's T1 equals 196 sine 55. Of course, I would expect most of you to go from this line to this line. But we punch that in our calculator and we get 239.3 newtons. So that's the tension in the wire. Second one is the compression. So the compression is this side. Again, I'm going to stick with the 55 newtons. It's always good to use an angle that's given to us in the question. There's no rule that says you can't use the 35.
All coaches and advisors who have...
So we could use that 35 degrees, but remember we calculated that. You know, we did 55 plus 90 minus 180, and if we made some silly mistake, now we're using that mistake further on. So it makes more sense to stick with the 55 degrees that we know and use it. So if we use 55, then C is the adjacent side, and 196 is still opposite, so we'll use tan. Tan 55 equals 196 over C, opposite over adjacent. Again, bring the C up and take the tan down. Punch that in our calculator, and we get 137.2 newtons. So you can check that, both those in your calculator, but now we can answer the question and say the tension in the wire is 239.3 newtons, and the compression in the pole is 137.2 newtons. So hopefully you'll see that today's questions aren't very different than the ones we've done before. So it's another chance for you to practice these types of questions and practice coming up with the diagrams. It's just a matter of getting used to some new language, stuff like compression, components, and so forth. So if you need to pause to copy the rest of this, go ahead. Otherwise, I'll flip the screen and get you to copy the homework down. So the homework then is going to be on page 84. And I want you to do a selected bunch of questions between 1 and 12. Pick the ones that you want to do the best on. Particularly find the ones that are similar to the ones we did today. I think there's a question about a tennis net and a chandelier and all that sort of stuff, and a plane taking off with vertical and horizontal components. Those are the ones we want you to look into. And hopefully you've had a good day. And so if you have, I'd like you to smile. Thanks. See you tomorrow.